Hey, welcome back to Mr. Pialis with Algebra. This is Unit 3, Topic 1, Lesson 1. We are going to be starting our statistics unit, and we're going to be diving into a look into the shape, the center, and the spread of data. All right, so we're going to start off with a bar graph, because this is something you probably have done in the past. First thing I want to do is put my labels down. So this is going to be days of the week. And then on the left-hand side, I'm going to put the frequency, how many times that it occurred. And I'm going to label my days of the week with Monday, Tuesday, Wednesday, Thursday, Friday. So I'm going to split this up. This will be Monday, M for Monday, TU for Tuesday, W for Wednesday, TH for Thursday, and F for Friday. And then I'm going to put my increments. I'm going to go by ones. 1, 2, 3, 4, 5. Remember, you don't have to label every single little line. That just makes it a little bit hard to read. I'm going to label each 5. Here we go. Monday, 4 people chose it. Bar graph goes up to 4 right there. Fill it in. Tuesday is 6, slightly more. Wednesday was 3. Thursday was only 2. That was the least. And Friday was the most. So it looks like there was more people who chose Friday than the next 2 choices combined. That's 2 out. That'd be 10 out of 25 people chose Friday. All right, so like I said before, we're going to be talking about measures of central tendency and measures of variation. Central tendency means the tendency to be in the center. 3 ways that you already know how to find the center of data, and that would be the mean, the median, and the mode. And we're also going to be talking about measures of variation, which is how far the data varies from each other, how spread apart it is. And that would be things like the range and the interquartile range. That tells you how far apart the data is. And then we're also going to talk about the shape, and the shape is how the shape, whether it's like in a bell kind of curve looking, or if it's tailed to the left or tailed to the right. We call that skew, actually, is the math word. So it's skewed to the left or skewed to the right. All right, so first thing, this lesson is about Alexandra and her mother, and they are doing a survey of how much time people spend watching Netflix. So we want to find the mean, the median, and the mode. So the first thing we do is you would put these numbers in order from least to greatest. It looks like there's 2 zeros. There's 1, 2, 3 ones. Then there's 1, 2, 3, 4, 5, 6 twos. 1, 2, 3 threes. 1, 2, 3 fours. And 1, 2, 2 fives. Almost there. And an 8. No 6s, no 7s, just 1 8. That person spends a lot of time watching Netflix. 8 hours. So, finding the median, that would be crossing the numbers off from the lowest and the highest until you found the number in the middle. Now, there are 20 responses, so you might know that if there's 20 numbers, then the numbers that are going to be in the middle are the 10th number and the 11th number. So I could do it that way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these 2 are the numbers that are in the middle. So it looks like they're both 2. Now, usually what I do is I would add them up and divide by how many numbers there are, but 2 plus 2 is 4. Divide by 2 is back to 2. Does that make sense? Because they are the same number. There's nothing in between. So I'm going to split the data in half and put a 2 up on top because that is the median. And what I would normally do for a box and whisker plot, which I'll do on the next page, is find the quartile. So I might as well just do it right now. There are 10 numbers here, so which means the 5th and the 6th number are in the middle, or you can just cross them off left, right, left, right, left, right, left, right. 1, 2, 3, 4, 5, 6. So it looks like 1 and 2 are the 2 numbers in the middle. So in between 1 and 2 is 1.5, or you can add the numbers that make 3 and divide by 2 is 1.5. So that's the lower quartile, because that is the middle of the bottom half of the data. The upper quartile is the middle of the upper half of the data. 1, 2, 3, 4, 5. In between 4 and 4 is 4. And then you've got your lower extreme, which is 0. That means your lowest number. And your upper extreme is 8, which is your highest number. So those are the 5 points that you need in order to make a box and whisker plot. We'll get to that in just a moment. To find the mean, you would just simply add up all the numbers and divide by 20 because there are 20 numbers in the data. I'm going to skip that. You can do that yourself if you have some time. And the mode is just the number that repeats the most. And it looks like there's 5 2s, so 2 is the mode. There can be more than one mode. So if there was another number that also repeated, there was 5 times, there could be 2 modes, there could be 3 modes, there could be more than one mode. There also could be no modes. If all the numbers or the pieces of data were all different, then there'd be no modes. Don't write 0 because 0 would imply the fact that 0 is the mode, and that would be an incorrect answer. So if there's no mode, make sure you write the word no mode. All right, so as I talked about, so upper lower quartiles and upper lower extremes, we've already found them, 0, 1.5, and 2. So I'm going to label those points. 0 is about right there, 1.5, there's 2 right there. And 4 and 8, 4 was the upper quartile and 8 was the upper extreme. So it's easy way to make your box and whisker plots is to put a vertical line going through your middle 3 points, and then connect them. That makes them into a box like such. And then you connect your outer points with your whiskers. Now, what does this tell us about the data? Well, it tells us that, well, if each part is 25% of the data, these numbers are very close together, where these numbers are much more spread apart. That does not mean that this little tiny box represents less numbers. It just means that those numbers are closer together. They're all the same amount of numbers. They're all 5 numbers. 5 here, 5 there, 5 there, 5 there. There were 20 people surveyed altogether. So please don't forget the size is how far apart the data is, not necessarily how many numbers there are. So which measure of central tendency would be the best? Typically, when you have an outlier, a number that does not belong, it's either way big or way small, you would say the median is the best, because outliers do not affect the median. When you find the median, you simply cross off the outlier and it is not affected into the answer. Whereas a mean, you actually have to add the outlier, and therefore it makes either the outlier, if it's too big, makes your mean higher, or if it's too small, it makes your mean lower. So it can affect means. Now, mean can be more precise. Now, if you look back, mean is going to be a decimal most of the time, and therefore it's more precise. So mean is a better choice, but not when there's an outlier. And if the mode is significant, and I know that's kind of a subjective term, but if it's significant, meaning that like 1/3 of the data is the same number, then I would say that mode is the best choice. Now, I know it's kind of unreasonable to say half, and like I said, it's subjective, so you can say if like 25% of the data was the same number, I probably would still go with mode as well, because I think that's significant enough that it's repeating enough times that that would be the best center number. Now, it is possible that the mode could be the lowest number or it could be the highest number, and I would probably ignore the mode in that case because that doesn't really make sense. How could it be the center if it's the lowest or the highest? All right, so that answers question number 3. This is a bar graph. So you got a bar graph, and I want to talk about skew now. So if I draw a line going over the bars, you'll notice that it has like a tail going to the right-hand side. So we call this skewed right. Now, I know that doesn't really make sense because you would think if most of the data is on the left, why would you say it's skewed right? Well, that's just the way it goes. If most of the data is on the left-hand side, it's skewed down to the right. So that's the reason why it's skewed right. If most of the data was on the right-hand side and it was tailed down to the left, and that would look something like this. This would be the tail and the data would be like that. That would be a skewed left. Now, if it looks like a bell, like this, where most of the data is in the middle and it's pretty even on both sides, then you call that a normal distribution. So those are the 3 ways that data can be spread apart. So a bar graph and a box plot. So the bar graph is pretty good for finding the skew because, like I just showed you a second ago, you could see that that one was skewed to the right. It's a little bit harder to find the center in this case because you can't find the median very easily on a bar graph because you don't have numbers that you can cross off like you can in a box plot. A box plot shows you where the median is, so it's much better for finding the center. Whereas a bar graph is probably more better for finding the spread of the data. I'm sorry, not the spread, the shape of the data. And then the spread of the data, I probably would go with the box plot because the box plot, once again, shows you where the data is. So if I flip back here to the box plot, it shows you how spread apart the data is. Now, in this case, the box plot only shows you in fourths, which can be a little bit misleading because you're not seeing all of the data, but it is showing you just those fourths. So different amounts of data are going to show you different answers. And last but not least, we have our homework. Now, I've taken the liberty of already putting the numbers in order from least to greatest, so I need to now find the median. There are 15 numbers, so that means the 8th number is going to be in the middle, 7 below it and 7 above it. 1, 2, 3, 4, 5, 6, 7, 8. So that looks like 2 is the median, which is a half. I'm sorry, I said 2. It's actually a half. And so this is the mom's data. And you'll notice that the mom's data, the numbers are much lower because I guess adults watch less Netflix than the kids did. But we'll see what happens in the end. So the half in the middle, I'm going to put a line through it because it's not a part of the bottom half. It's not a part of the upper half. It's just simply in the middle. So now we have 1, 2, 3, 4, 5, 6, 7 numbers below it in the bottom half, and that would be the 4th number in the middle is the quartile. Or you can just simply cross off like this, lowest, highest, lowest, highest, lowest, highest, and see that 0 is in the middle. Now 0 also happens to be the lowest number. So this is going to be one of those weird times where the whisker is going to be non-existent because it's the same number as the bottom quartile. And then over here, 1, 2, 3, 4, it looks like 1 is the upper quartile and 2 is the upper extreme. So put my lines, vertical lines through the middle 3 dots. There is no whisker on the left-hand side, and there is on the right-hand side, so there's your box plot right there. How does the box plot compare to Alexandra's box plot? Be sure to compare shape, center, and spread. Well, the spread of the data over here was so close that it's actually the exact same thing. It looks like they're all equally distributed, where there's no box that is bigger than any other. The center is right here at a half. Now, you'll notice that this box plot looks like it's stretched out just as much, but notice that the increments are going by quarters. Whereas if you go back here, that could be a little bit misleading. The increments were going by ones, which makes it look about 4 times bigger than it actually should have been. That makes this one, makes her mother's look 4 times bigger than it actually should have been. Compute the measures of central tendency. Which measure best represents the data? In this case, I would say there is no outliers, so mean is the best. If you find the mean, it's going to be a very precise number. Not saying that the median's not precise. Honestly, median pretty much is always a good measure of central tendency. You cannot make a set of data where median is not good. It's always good. It's just whether or not it's the best. I would say mean is the best because it's the most precise. It gives you the most specific answer, usually typically a decimal. So therefore, in this case, I would go with mean. All right, as always, thanks again for watching. Please give it a like if it helped you learn anything about box plots and how to analyze them and make them. And please subscribe if you haven't done so already. Thanks again for watching. Have a great day.